Okay, so we saw how to transfer data from SPSS from Excel sheet to SPSS, and then we saw how to transform data from one variable to another, and how to convert strings to numerical, how to clean up your data set, how to remove the missing values. Okay, so now you are done with the basics of using SPSS. Now we will be moving on to tests for normality. This is important because without testing the normality, we cannot see which test to apply for. Okay, all tests require you to test for normality first, then you can apply that test. Okay, otherwise only one test is there, that is a test of chi-square that does not require you to test for normality. So, and the test for normality are only applicable to continuous data. Okay, there are a few ways to test that. First we have the histogram, and then we have the QQ plot, and then we have the Shapiro-Wilk test or Kolmogorov test, and then one more, that is the skewness and kurtosis. Okay. Actually, we keep three things in our mind: histogram, Kolmogorov and Shapiro-Wilk test, and the last one is the skewness and kurtosis. And if the data set is justifying two of them, we consider that as a normal data. Okay. So let us start building it up. Okay. So we have to first go in the histogram one, and then we will go for the QQ plot, and then we will be okay. So let me just touch you guys with the basics. If the data is normal according to the histogram, it will have a bell-shaped curve. Okay, it doesn't have to be perfect. It should just be have to have a bell-shaped curve. What about the QQ plot? For the QQ plot, it should be represented as a straight line. The points should cluster around the line, and that's like that. Okay. And the test of normality, what is that? The Kolmogorov test is a standard one, and Shapiro-Wilk is used for small sample size, like such as 30 and stuff like that. And the Kolmogorov is for above sample size. Okay, Shapiro-Wilk is used for if you have a sample size from 30 to 1,000, and the Kolmogorov is for above 1,000. The significance column is interpreted as if it is more than 0.05, the data is considered normal, and if it is less than zero point 0.5, then it is not normal. So these three are the main one. And for skewness and kurtosis, that is later on discussed, the value should be between minus 1.96 to plus 1.96. Okay, this is positive and negative skewness. This is the data that is parametric. It is distributed across along the mean value. And this is the positive skew, and this is the negative skew. Negative skew means that the data has been disrupted by one term that has disturbed the and deviated it towards higher values. And positive skewness is deviated towards the lower values. For example, if there is someone who is like a billionaire and he is present here and his economic value is so much that he has disturbed the data. And if in another case there's starvation, then there is poverty, and that has disturbed the data towards this side. Symmetrical distribution is the data is normally distributed. It's across the mean. There are no outliers. Okay. Okay, so this is the bell-shaped curve here. This we also consider the bell-shaped curve, but it is here the bell is not complete. So instead of this one, we will consider this one as a normal data. Then we have the QQ plot. In the QQ plot, the data is distributed across the line. Okay. If the data is not normally distributed, we can go for transformation. We will be discussing that later on. And here, the Kolmogorov and Shapiro-Wilk test, the significance, if it is more than 0.05, we can say that the data is normal. Okay, so let us apply these tests. We can just apply them on the, we said on the continuous variable. So our continuous variable was the weight. Okay, so we will go here in analyze section. We will go in the, first I want to make a graph, histogram. I will go in analyze, frequencies, should come back here, weight here. Okay, histogram, and I say I want to show me the normal curve. Okay, continue. Okay. And here the histogram is shown. It's a proper, very beautiful bell-shaped curve. Okay, so one criteria for the normality graph satisfied. Okay, what I will do is I can even copy this and paste it with me in my Word document for where I will be writing the results, because I will need to show that my data is normal, or otherwise I can simply state that my data is normal. Both ways are okay. Okay, because we cannot make many figures, because some journals are like we just expect you to add 2 or 3 figures, and if I will be adding many figures, that will just disturb the things. Okay, okay, next one we have is here. Okay, let me go in this section, and I will go into the explore. I will go here, and I will go for the statistics. What I want is I want the plots. I want the normality plots with test, and I want also a histogram. Okay, and that's good. Continue. What about, yes, I want the both the statistics and the plots. Let me see now. Okay, so this is the bell-shaped curve. Last time it was properly showing a curve that was very perfect, and here it's not showing that. And now I have this one. These values are distributed across the line. So again, this is also satisfied. Okay, now we have this one, the Kolmogorov and the Shaprov-Wilk test. The significance is more than 0.05. This value of significance, it is more than 0.05, the p-value. So once again, it is normal. And the skewness and kurtosis, it is between minus 1.96 to 1.96. Yes, skewness is between minus 1.96 to 1.96, but kurtosis is out of that. But this data set is satisfying the Kolmogorov and the bar chart and the QQ plot. So we would say the data is normal even if one variable is not normal. Okay. So in this Kolmogorov and Shaprov-Wilk test, we will not be looking at the statistics and the degree of freedom. We will be just looking at the significance. Okay. So that was about the normality. And one more thing left. Yes. We saw this one, we saw this one, we saw this one. Okay, now we have to see if your data is not normal, what will you do? Because according to this, does the data fit a normal distribution? Great, use a parametric test. If it does not use, if it's not normal, you have to either use a non-parametric test, but the non-parametric tests are not that good. Okay, unless you have no choice, and rather than to use a non-parametric test, you will use a non-parametric test, but first you will try your max to go for a parametric test, because many other journals that are like very high category journals, they expect you to apply parametric test because they have more quality and more efficiency. So what to do if the data does not come out to be normal, if it does not satisfy this? You can try two transformations. Okay, transformation of course only work for two data. You can either use a log or you can go for square root. Okay. Okay, square root cannot be used on variables with negative number. Log cannot be used on zero and negative numbers. Okay, and you can, yes, non-parametric tests are weaker, so they're only used if the parametric ones cannot be. Okay, so suppose this is my data set and it turns out to be not normal. What I will do is I will go into this transform compute, and I will take the square root of this square root. I will use this one, and I will hide the weight. Remove this. Okay. I will say square root weight. This is the output window. I always close it because it just makes everything confusing. Now I have made the square root of it. Again, I will do what I will do is I will take the log of it. Oops, sorry, I took the wrong one. Here I will write log. Okay. And then I will repeat all the steps that I did for the normality one. And if the data comes normal for the square root one, I will be using these values. And if it comes negative for positive for normal for this one, I will be using these values. But and if it does not come normal for both of them, then automatically I will have to go for the non-parametric test. But now I have tried many my years. First I went for my original data, and then I square root took the square root, and then I took the log, and the data was not coming normal. I have no choice then to go for the weak test, but the non-parametric test. Okay, so that was it.